Alright, we got the man-woman question. I hate this one a lot. It kind of sucks, but that's okay. It's not okay. That's okay, because I'll show you how to do it. Yeah, woo. Man-woman question, my favorite. So that's number 4 on the 3.9 worksheet. It's also in the 3.9 textbook. I think it's like the second to last one that was assigned to us, if you want to look at that. Again, these aren't the exact same questions on the test, but they are the same questions with different numbers. So this is just going to show you guys to do it, and it's on the test because I already went over the lore. All right, so a man starts walking north at 5 feet per second from a point P. 5 minutes later, a woman starts walking south at 7 feet per second from a point 500 feet due east of P. At what rate are the people moving apart 10 minutes after the woman starts walking? Round the result to the nearest hundredth. So we have point P, where the man starts walking, and he starts going north. And then 500 feet east of P. Go this way. And this is 500 feet. There is a woman, and she's going south. So we're gonna go down here, and this looks like a bad symbol, but I promise it's a diagram of where the man and the woman are walking. I guess. Okay, so we're gonna let M represent how far north the man has gone, and then W is gonna represent how far south the woman has gone. And now, what we have to find is at what rate are the people moving apart 10 minutes after the woman starts walking. So we're finding the rate at which the man and the distance between the man and the woman is increasing. So how do we, what line would represent that? Well, the man in our diagram is currently right here, and the woman in our diagram is right here. So if we were to connect it with a line, that would represent the distance between the man and the woman. And I'm going to drop my camera for this. Okay, I drew the line, and so this line represents the distance between the man and the woman. So this line will be represented by Y, and what we're finding is at what rate are the people moving apart. So at what is the rate at which Y is increasing? So that's going to be dy over dt at 10 minutes after the woman starts walking. So what we're going to do is, I mean, it's hard to tell what you're what do you do with this? Well, we're gonna have to solve for a few things here. So what we're gonna do is we're gonna make a right triangle. So we do this, and we do this, and now we have a right triangle with Y as the hypotenuse. And what are the legs of this triangle? Well, we have Y as the hypotenuse. We have 500 feet is the bottom leg here, because this is gonna equal this. And then we have this right here is the value of M, and this is going to be the value of W. So this whole leg right here is M plus W. And I'm gonna draw this triangle a second time so that it's easier to see. So 1 second. Alright, so we have Y is the hypotenuse, and then the two legs are, well, this is 500 feet, and then this is going to be M plus W. So let's look at what else the equation gives us. It gives us that the man starts walking north at 5 feet per second. So we know that the rate at which the man is walking north, the rate at which this line is increasing, the rate at which M is increasing, I guess you could say, dm over dt is 5 feet per second. It's hard to write because it's at the edge and I can't hold the paper with one hand. Okay, 5 feet per second. Now, what else does it give us? 5 minutes later, a woman starts walking south at 7 feet per second. So, the woman is walking south, and the rate at which W is increasing, dW, like the Arthur character, yeah, I know, equals, over dt, equals 7 feet per second. So, what can we do this with? Well, what can we do with this? Well, we have the triangle here, And we can make the equation with the Pythagorean theorem. Y squared equals m plus w squared plus 500 squared. And remember, we have to solve for dy over dt. So we're going to find the derivative like we normally have for the last two problems. We have 2y. Okay, it's focusing on my hand again. Okay, we have 2. Why? It's not that important, man. 2y times dy over dt, because remember, we take the derivative and then we add dy over dt because there is no time involved, equals the derivative of this is going to be 2 times m plus w, and then how we do this is going to be dm over dt plus dw over dt. Now, how this works, and you don't necessarily need to know how this works to get this as the derivative more so than you just need to know to do this when you do this question on the test. But how this works is basically we have m plus w, and we're getting the derivative of that relative to time. So for this, dm over dt would be that, and then we have the plus, so then plus dw over dt. Now the 500 is 0, so yeah. Okay. And so we have to solve for dy over dt, because remember, that is what we're trying to get. Dy over dt 10 minutes after the woman starts walking south. How can we do that? Because we don't have y, m, or w. We do have dm over dt, and we do have dw over dt. But the other three variables we don't have. Well, let's go back and check. So it tells us that we are finding the rate at which they're moving apart 10 minutes after the woman starts walking. So we know that 10 minutes after the woman starts walking, and we know that the rate at which the man and the woman are moving. So we know that, well, the woman has been walking for 10 minutes. And we know that the woman has also been walking at 7 feet per second. So, first thing we have to do is convert those 10 minutes into seconds. So it's going to be 10 times 60. And then, once it's converted to seconds, we can multiply that by 7, because she's walked 7 feet for every second. So, and then W is going to equal 10 times 60 times 7. So 10 times 6, okay, no, thank you, times 7. And that's going to be 4,200. 4,200, all right. And the man, well, let's look again, just to make sure. So the man has been walking for 5 minutes longer than the woman, because it says a man starts walking north at 5 feet per second from a point P. 5 minutes later, a woman starts walking south. And then we're finding this relative to, well, 10 minutes after the woman starts walking. And the man's been walking 5 minutes longer than the woman. So we know that we know that the man has actually been walking for 15 minutes, because the woman's been walking for 10 and the man's been going for 5 minutes longer. Therefore, the man's been walking for 15 minutes. So we convert this 15 into seconds by multiplying it by 60, and then we multiply it by 5, because after this is converted to seconds, he's walked 5 feet for every second. And then m is going to equal 15 times 60 times 5. So 15 times 60 times 5, 4,500. So m equals 4,500. Now we have to solve for y. So y, remember, is going to equal y squared equals m plus w squared plus 500 squared. Now, how do we solve for this? Well, we have m and w, and 500 squared is 500 squared. So now it's just y equals the square root, and plug in m and w. So we have m is 4,500 plus w is 4,200 squared plus 500 squared. And let me move this over here. Y equals, so then 4,500 plus 4,200 is 8,000 or 8,700 basically. So now, 8,700. Now we find the square of that, and we add it to 500 squared. So plus 500 squared. And now we have y equals the square root of whatever this number is. I think it's 7... Okay. 75,940,000. Yeah, okay. That's all. So it's the square root, because remember we have the square root in there, of 75,900,000. Oh my god. I'm just gonna write this out. Hang on. Okay. So we have y equals 75,940,000. There are 4 zeros at the end of that. Yeah, okay. So now we have all the numbers we need to solve for dy over dt. So first of all, we can cancel these 2's out because there's a 2 on each side and they're both being multiplied. So now we have y equals, oh no, I'm not right, no, not y equals, I'm a fool. Okay. Y times dy over dt equals, let's plug in, or I should probably plug in all the numbers. Yeah, I should plug in all the numbers. Okay, well first, I'm going to isolate dy over dt so it's easier. So we're going to divide y on each side. And y, so we have dy over dt equals m plus w times dm over dt plus dw over dt all over y. And now we have dy, if it'll focus please. Okay, dy, why? My hand is not that important, man. Dy over dt equals, and we plug in our numbers, so we have m is 4,500, 4,500 plus w is, where's w? 4,200, 4,200 times dm over dt plus d. So dm over dt is 5 plus dw over dt is 7. I'm gonna fix the parentheses. And then all over y, if I can draw a division line correctly. Okay, all over, I didn't, hang on, let me just, guys, I drew the division line, look at that. Alright, all over y, which is the square root of this number, which I'm not going to say again because I forgot it. So 7594 with 4 zeros at the end. Right? Yep. And now we just plug it into the calculator, so. Let's see, 4,500 plus, oh, that is a minus, plus 4,200. Multiply that by 5 plus 7, which is going to be 12. And then we divide it by, let's see, 7594, 0, 0, 0, 0, square rooted, so to the 1/2 power. And our answer is going to be 11.98. So dy over dt equals 11.98 feet per second. Because remember, this is the rate at which the distance between the man and the woman, or the man and the woman, is increasing. And that will be our answer, which is the correct answer because it's right here, and I checked it earlier, so it's okay. All right, that's all for this problem. Let me know if you're still confused on any of it, and I will do the other two soon, hopefully. Okay, goodbye. I'm running out of time.